A sample of blood pressure measurements is taken for a group of adults, and those values in millimeters here, Hg, are listed below. Now, the values are matched so that 10 subjects each have a systolic and diastolic measurement. We want to be able to find the coefficient of variation for each of the two samples and then compare the variation. So we want to be able to find the coefficient of variation for the systolic measurements and then the diastolic measurements. Now, the one thing that we need to do is, in order to use the formula, we need to find the sample standard deviation and the sample mean. So what we're going to do is we're going to open up this data in a StatCrunch. Now, when we open up this data in a StatCrunch, we should see our two columns, systolic and diastolic. We're going to go to Stat, select Summary Stats, and then go to Columns. And then we're going to make sure that you hit the Control button to make sure that both of these are now placed over here. Now, what we want to be able to find is the mean, the sample mean, and the sample standard deviation. So let's go ahead and compute. So there is our sample mean and sample standard deviation. So what I've done is, it's here. So here is our standard deviation and our sample mean. So we're first going to work with the systolic. So recall that the formula for the coefficient of variation is equal to the sample standard deviation divided by the sample mean times 100%. So therefore, what we're going to do is we're going to put the sample standard deviation, which is 18.793912, and divide it by the sample mean, which is 127.9, and then we're going to multiply it by 100%. Now, once we multiply it by 100%, we're going to write down our result at 14.694%. Now, the reason why I'm cutting it off at 3 decimal places is because the question is asking us to round it to 1 decimal place. So therefore, I can see what's going on here. Therefore, I'm going to round it to 1 decimal place, and I get 14.7%. Let's go ahead and put that answer and make sure that we got it right. So for systolic, 14.7%, and there is our answer. Now, let's go back and work on the diastolic. So for the diastolic, again, our formula for the coefficient of variation is equal to the sample standard deviation divided by the sample mean multiplied by 100%. Now again, let's take a look now at the diastolic standard deviation and mean. So the standard deviation for the diastolic is 12.002315, and we're dividing it by the sample mean of 72.5, and then we're going to multiply that by 100%. So again, what we're going to do is we're going to write this out to 3 decimal places because we're rounding it to 1 decimal place, so we have 16.554%. So when we round that to 1 decimal place, we get 16.6%. Let's go ahead and put that into our result, see if that works. So we have 16.6%, and there is our answer. Now it says we want to be able to compare the variation. So we would say the coefficients of variation for each data set are, okay, it's not more than 5% points, because if you subtract these two, it's less than 5%. So we'd say that it's within 5% points of each other. Therefore, the systolic measurements vary, and we would say that about the same as the diastolic measurements.